We're going to do the scale in the solar system. And the first thing you have to read is the article. So you get the article on Canvas. You're going to go to scale in the solar system. You can see it's kind of a long article. It's 8 paragraphs. Yeah, 8 paragraphs. But it's only about a 7-minute read, and my husband even read it in 6 minutes. You can click here to have it read to you in English by me or my husband. So let's go ahead and read and also get oriented to what we're doing. So we have this here in front of us, or we have the digital version, which is right here. If you have the digital version, you need to make a copy, just like I did, and then realize that you're going to have to click into, you're going to have to edit. Sometimes on some of these, you're going to have to go to edit picture in order to get there. So let's go ahead and see, what do we think this article is going to be about? We're going to preview it, look at the pictures, and read the subheadings. So let's do that. So we see the picture. I see some pictures of some gorgeous sky. And also see like a tent. So it makes me think of camping or anything like that and seeing the stars. I see this model here about how many Jupiters could fit into our sun, which is a lot. And then the something similar to what we've done in our book. So I think this is going to be about the solar system, and it's called Scale in the Solar System. And then there's these 2 subheadings. The first subheading is objects in the solar system come in different sizes, and then different planets are different distances from the sun. So in order to activate, you're just going to write down, what do you think this article will be about? And I think it's going to be about scale in the solar system and maybe stars. And it's going to have distances. Okay, great. Do I know anything about this? Yeah, I have some prior knowledge. We made that thing yesterday about it, so I might write scale model. And anything else I know about any of those things. And what do you want to learn, or what questions do I have? Whew, I'm not sure what questions I have or what I want to learn, but I want to learn something new, at least one new thing. Okay. So I'm going to fill that out. You don't have to fill it out the same as I do, but you're your own person. And the more you can bring and activate your own mind, the better you're going to be at retaining information, which is remembering information. So let's go back to the top of the article. Okay, you see this picture. And I'm going to read. So I'm going to write my name on my paper. And today's date, which is the 8th. And the period, whichever your period is. And then draw a picture. You can leave that if you want to do that afterwards. So, and the word art is just using 3 keywords and making them look pretty. Let's leave those 2 boxes. So for right now, let's leave those 2 boxes blank. And let's flip pages and go and look. The directions say here, and I'll show you here digitally. So I left these 2 blank for right now. As you read the article, use bullet points to write one important detail or sentence from each paragraph in the boxes below. Okay, so I have 1 box for each paragraph. All right, so let's go ahead and start reading. In 1969, millions of people watched as humans visited the moon for the first time. Since then, many astronauts have visited the area of space that's just outside Earth's atmosphere. We've even built the International Space Station, which circles the Earth and allows astronauts to live and do research in space. We have also explored more distant areas of the solar system using probes, which are a spacecraft without people on board. However, humans have never set foot anywhere else in the solar system. Technology that helped humans travel and survive in space has improved since that first trip to the moon. So why haven't we traveled to any other planet? The answer lies in distance. Compared to the rest of the solar system, Earth is just a tiny dot surrounded by a whole lot of empty space. I think the most important thing from there is that last sentence. So Earth is surrounded by a lot of empty space. Now you can write it in a sentence or you can write it in some details. I'm just doing bullet points here. Earth is surrounded by lots empty space. Or maybe my detail that was that humans have never set foot abroad anywhere. Okay, so let's go ahead and read the next one. Okay, so this is what I have here. I just wrote a bullet, kind of notes. I didn't write finish space. Okay. All right, paragraph 2. Objects in the solar system come in different sizes. So we're talking about things in the solar system, different sizes. Okay. Earth is just one object in the group of objects we call our solar system. Our solar system includes the sun, the planets that move around the sun, and the moons that move around the planets. Okay. Some of the objects in our solar system, like the sun and the planet Jupiter, are so big they're hard to imagine. Others are very small, aren't very big at all. Some moons are only 3 or 4 kilometers. So I think I'm going to rate different sizes. Some small, some big. Some big, some small. Just writing this down. The second paragraph, bullet points. All right, let's go to number 3. There are 8 planets in our solar system, and they vary widely in size. Planets close to the sun are smaller, while planets far from the sun tend to be larger. I feel like that's kind of important, so I might want to write that down now. So planets vary means that they differ. They're different in sizes, excuse me. And then close to sun, close equals smaller. Okay, so that's what I wrote down so far. I might have to add something. Planets close to the sun are smaller, while planets far from the sun tend to be larger. In comparison with the rest of the planets, Earth is in the middle. It's the 3rd planet in distance from the sun and the 5th largest planet in size. You could have written that. Earth is in the middle. The smallest planet in our solar system is Mercury. If Earth were hollow, about 18 Mercuries would fit inside. The largest planet in our solar system is Jupiter. That's so big that more than 1,000 Earths could fit inside. So, did my summary do it? Yeah, planets vary in sizes. We have big and small. Big and small, something like that. All right. Usually if it's a picture, that means it's important. Okay, so I see the scale model of how many Jupiters. Many of the planets in our solar system have moons, objects that travel around planets. Earth has one moon, which sometimes see in the night sky during the day as well. If Earth were hollow, about 49 moons would fit inside. Mars has 2 moons, and Jupiter and Saturn have many more than that. Jupiter has at least 63 moons, and Saturn has 62, but scientists are still identifying more. Most moons aren't very big, but even moons vary a lot in size. Ganymede, a moon of Jupiter, is the largest moon in our solar system. It's larger than the planet Mercury. Now, if I'm going to be honest, I kind of got lost in that paragraph. Okay, there's lots of moons. They're talking about moon, all these different numbers. I'm not going to remember all of them. Okay, but I'm going to jot down some big things. Many things have moons. That's my big idea. Many planets have moons that travel around. If I want to put an example, I can strengthen it. Okay. All right, so we got the first half done. We have 4 more paragraphs. Let's look and see what this next picture shows us. It looks very similar to yesterday's. Okay. Again, before I go on, if I'm typing this in, what I would do is I would go here, like for example, for my paragraph 4, I would hit edit and I would type it in. I'd find my thing and I'd type it in. Okay, and I wrote something like a bullet, something like that. Many planets have moons that travel around them. So I could just save and close, and I could have it, and I could just come clean it digitally. Okay, if I wanted to make it into a bullet, I would just go here and I don't know where the bullets are here, so just do a dash. Okay. All right, So I'm going to continue to write on paper because writing, the actually act of writing can activate your brain. So here's what I have so far, and I have 4 more to go with the 4 paragraphs. Planets in our solar system come in a variety of sizes, but they are much smaller than the sun, all much smaller than the sun. To show the sizes of the planets accurately, the illustration shows them much closer together. So it's scaled for size, but not distance. All right, so this next half is talking about how they're different distances. So we had vary in size, and now the second half seems to be about distances. All right, so let's see. Ooh, it's a big paragraph. The objects in our solar system don't just vary in size. Each is also a different distance from the sun. Okay, the closest planet is Mercury, about 57 kilometers from the sun. That may seem far, but it's nothing considering how big the solar system is and how far away some of the other planets are. The farthest planet is Neptune. It's 4.5 billion kilometers from the sun. The distance of each planet from the sun makes a big difference in its climate and whether it can support life. So I'm going to capture that so far by saying they vary in, or they have different distances from the sun. From the sun. I might add another one, how that affects the distance from the sun affects the planet. So hopefully this helps you guys here. Let's see. Okay, planets are close to the sun, like Mercury and Venus, get a lot of energy from the sun and are too hot to be habitable. There's that vocab word, meaning they can sustain life. Planets are very far from the sun, like Uranus and Neptune, get much less energy from the sun and are much too cold to be habitable. So the further away, the colder you are. For example, far equals cold. So that's just something for me to remember so I can write my summary about them. On these planets, water exists only as ice. Earth is about 149 million kilometers from the sun, which is good news for living things. Earth can support life partly because it has liquid water, and it has liquid water because it is just the right distance from sun. So I might even write that into Earth equals, quote, just right. Or maybe you want to just write just right and you'll remember it. Okay? Again, if you're doing this digitally, what you'll do is you'll just do the same thing. You'll go to your paragraph, you'll hit edit, and you'll continue. Okay? Save and close, and then you'll go on. All right, 3 more paragraphs. This isn't too bad. Since all the planets in the solar system, including Earth, are always moving around the sun, the distances between them are always changing. Okay, I'm going to write that down. Distances are always changing. And my symbol for change is a triangle. That means delta. Changing, just change. So I wrote that like that. Distances are always changing. When scientists send spacecraft out to explore other planets, they must think about where each planet will be at a certain time and when it will be easiest to reach. Even when our closest neighbor planets are as close to Earth as they can get, they're still very far away. Earth's neighbor planet Mars is so far away that it takes 6 months to get there by rocket. Other planets are much farther from Earth than Mars is. A spacecraft launching from Earth would take about 12 years to reach Neptune. So the distances are always changing, and I would say that the distances are huge. Because if it can take 6 months, which is our closest, it's still a long time to travel. Are really big. And I might put in the EX, for example, that I might like remind myself I want to include a little example. All right. Okay. And the last, oh, that's my last paragraph. Cool. Okay, so I have an extra paragraph here. With all this empty space around us, it's no wonder humans haven't traveled very far from Earth. Sending people into space and bringing them back safely is complicated. Scientists must take into account the amount of fuel, needed to stay in space for months or years at a time, the weight of all the food and equipment astronauts need for a long trip, the way the human body might react to the conditions on other planets, and lots of other important information. Still, many people are working on solving these problems in hopes of sending humans to other planets someday. All right. So the NASA, National Aeronautics and Space Administration, NASA currently estimates that humans may make it to Mars in 2030. Okay. So again, I would say mostly empty space. Empty space. And that's why, and I'm going to put an arrow for me to show that's why. Kind of like that. My arrow. That's why humans haven't explored much. Okay. So that's just the first part of what you have to do is you have to read it and take some notes. So I'm going to stop the video there. And then if you want help with the summary, we'll go from there.